Okay, so we are going to see the next point from multi-degree of freedom, and that point is influence coefficient. Now, what is this influence coefficient? See, to solve the problems like matrix iteration method, will require the equations not in the differential form, but will require the equations in the influence coefficient form. Means x1 equal to a11 f1 plus a12 f2 plus a13 f3 plus a14 f4 till n number of masses, displacement and forces. So if we are having n masses, then it will be, last one will be a1n fn. Similarly, we can write x2 is equal to a21 f1 a22 f2. Now what is this a11 a12 a13? This a11 a12 a13 is called as influence coefficient. Basically it is flexibility influence coefficient. So here you can see I have written aij, which is flexibility influence coefficient. तुम्ही simply त्याला काय म्हणू शकता, influence coefficient. So when we call only influence coefficient, that is, it is flexibility influence coefficient, means displacement is represented in the form of A into F. A into F. Now similarly x2, x3, xn, you can write n number of equations. If I want to convert all these equations into matrix form, then the matrix will be x1, x2, x3 till xn. Here we are having f1, f2, f3, f4. So f1, f2, f3 till fn. And along with this f, it is multiplied by a. A means influence coefficient. So I can write here a11, a12 till a1n. a21, a22 till a2n. Similarly, a31, a32, a41, a42 till an1, an2. So the whole equation is converted into x is equal to a into f. So x displacement is equal to, कुणाचा matrix आहे, flexibility influence coefficient matrix into force. So we can represent or we can write the equations in the form of influence coefficients. Now there is another one type of influence coefficient which is used, and the second type of influence coefficient is called as Kij, which is stiffness influence coefficient. So when we use stiffness influence coefficient, then we can write the equations in the form of f1 is equal to a11 x1 plus a12 x2 plus a13 xt till n. So here if you see the difference, here the displacement is represented, here the force is determined in terms of displacements. Similarly, you can write f2 is equal to till n number of times. So if I want to convert this, means stiffness influence coefficient equations in terms of stiffness influence coefficients, then we can convert all the equations f1, f2 till fn will be equal to, here we are having displacements. So I'll write a displacement matrix x1, x2 till xn, and along with displacement we are having, this influence coefficient is stiffness influence coefficient. So instead of a there will be k. So k11, k12, k13. So I can write k11, k12 dot 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 k1n. Similarly for to k21, k22 dot 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 k2n. And similarly we can write for kn1, kn2 dot dot dot. Last will be knn. Okay, so the matrix of this influence coefficient will be n by n. So this is the force matrix, this is the K stiffness matrix, stiffness influence coefficient matrix, and the last one will be X displacement matrix. So बघा F is equal to काय परत KX, म्हणजे हा काय stiffness influence coefficient. In reverse, flexibility influence coefficient. Okay, so we can represent the equations in terms of influence coefficients. So the influence coefficients are used to solve the equations. Now we'll see what is Aij and what is Kij. First we'll see Aij. Aij means it is the displacement. It is the displacement at I due to unit load at J. Means here we are going to consider force as 1 and we are going to determine the static deflection. Static म्हणजे काय? In working condition नाही. First we will apply the force to that particular mass and we will determine the displacement. So suppose if I write A12 means displacement at 1 because of unit load at 2. So when you are going to consider unit load at 2, then the load at remaining masses will be equal to 0. That will have to consider. So हे म्हणजे काय displacement at I due to unit load at J, and जी displacement ती कशी आहे static. Now similarly I can say that for Kij हे काय होतं डिस्प्लेसमेंट, म्हणजे हा काय असणार आहे फोर्स. रिव्हर्स करायचं. सो फोर्स ॲट आय ड्यू टू युनिट डिस्प्लेसमेंट ॲट जे, म्हणजे फोर्स लावायची म्हणजे काय करायचं आता वी आर गोइंग टू डिस्प्लेस दॅट मास अँड बिकॉज ऑफ द डिस्प्लेसमेंट व्हॉट अमाऊंट ऑफ फोर्स इज जनरेटेड दॅट विल हॅव टू डिटरमाइन. सो Kij means force at I due to unit displacement at J. So K12 means force at 1 due to unit displacement at 2. Okay, so by using this influence coefficient we can solve the multi degree of freedom problems. त्यातला बहुतेक आपण एक प्रॉब्लेम बघितला आहे कुठला मॅट्रिक्स इटिरेशन मेथड. इन दॅट मॅट्रिक्स इटिरेशन मेथड वी हॅव यूज्ड दिस Aij, that is flexibility influence coefficient. Now in this flexible influence coefficient we will require one theorem, and that theorem is called as Maxwell's reciprocal theorem. Maxwell's reciprocal theorem. हा theorem काय आहे बघा, if I am having the value of A12, then if I take the reciprocal, then its influence coefficient is same. So A12 will be equal to A21. Similarly, A23 is equal to A32. बरोबर आहे, म्हणजे या सगळ्या व्हॅल्यू काय असतात सेम. सो इफ यू नो द व्हॅल्यू ऑफ A12 then there is no need to find A21. The value of A12 and A21 will be same. So we are going to use this Maxwell's reciprocal theorem to determine the flexible influence coefficient. पहिल्यांदा we'll determine the flexible influence coefficient by using FBD, and then we'll use the Maxwell's theorem to identify the remaining stiffness or flexibility influence coefficients. Okay, मग आता ह्याच्यावरती आपल्याला एक प्रॉब्लेम बघायचा आहे. पेपरला असा प्रॉब्लेम येतो, डिटरमाइन द इन्फ्लुएन्स कोइफिशियंट, कुठला पण असेल, आयदर स्टिफनेस और फ्लेक्झिबिलिटी. मोस्ट ऑफ द टाइम फ्लेक्झिबिलिटी इन्फ्लुएन्स कोइफिशियंट विचारणार आहेत. सो आय एम गोइंग टू टेक वन न्यूमरिकल ऑन फ्लेक्झिबिलिटी इन्फ्लुएन्स कोइफिशियंट. ओके, न्यूमरिकल घ्यायचं आहे, तोपर्यंत तुम्हाला पाय असलं तर लिहून घ्या. पेपरला जर याची थिअरी विचारली तर हे व्यवस्थित एक्सप्लेन करायचं.